Hello everyone and welcome back to our course. In this lecture, we're going to learn another type of analysis to estimate risk known as Monte Carlo analysis. So for that, we're actually going to define a new function to keep the functionality contained. And we're going to call this, Monte Carlo analysis. We're going to pass in here a starting price, our days of the year that we want to calculate the risk for, as well as our average MU associated with the drift, and sigma, which is the volatility of the stock. Then let's open up that function. All right, first we're going to calculate price, and for that we're going to use a NumPy array of zeros, which means we're just going to have an array full of zeros, and we pass into the argument of this function the size of the array. The size is going to be days, so it's going to equal the number of days that we pass into the function. Then price at the 0th index should be the starting price. So we're setting here the initial price. Next, let's define a shock variable. We're going to use numpy.zeros again on the number of days, as well as a drift variable. We're going to use numpy.zeros of days. Next, we're going to loop for every day in a range starting from 1 up to our number of days, because we already set the 0th index. We're going to take shock at that day and use numpy.random.normal to create a new random number. We're going to pass in a lock value, which will equal our MU argument multiplied by dt. dt, that is going to be 1 divided by our days. So let me just define here. I'm going to define days and dt outside of the function. Days is 365 and dt is 1 divided by days. As well, for the random.normal function, we're going to pass in a scale argument, and for that we're going to use a value known as sigma, which is the volatility of the stock, the argument that we're passing in, multiplied by numpy.square root of our dt. So let's define sigma. Sigma, we're going to take our returns and use the standard of it, as well at the specific stock we want. Let's use how about Netflix stock? All right, and MU here, let's define that as well. MU is going to equal our returns dot mean, so the average, again, at that same stock. We can use Netflix stock. All right, and after that, we have defined shock. So let's define drift at that current day, so for every day. Drift is equal to our MU, so our average multiplied by the dt. And as well, we want to define the price array at that day. The price is going to equal the price at the day minus 1, so the previous day's price, plus the price at day minus 1 again, multiplied by the drift at that day, plus the shock at that day. So that's the formula for calculating the stock price. You take the previous day's price and you add the previous day's price multiplied by the drift plus the shock. Then after that, make sure you exit the for loop with a backwards. So make sure the indentation is outside of the for loop and return the price. So we're going to have the price returned, and that will be an array. So now how do we call this function? All right, well, we're going to loop through all of the indices in our price array. So for every run we want in any range, like 100 runs, we're going to use pyplot and use the plot function to plot our array. What is our array? Well, our array is actually what Monte Carlo analysis returns. So I'm going to let me just call Monte Carlo analysis. I'm going to pass in my starting price, my days, my MU, and my sigma. The result of this is going to be my price, which I can just have as a variable, and then I can plot the price. Now, we do have to define the starting price though. So let's figure out starting price. We're working with Netflix here, so I'm just going to create a new code cell, and here I will define my starting price. All right, and my starting price is going to be the first value inside of my Netflix array. So I can just grab Netflix and call head to get the first 5 rows from that stocks data set, that data frame. And we can see that the first value is 372.82. And that is going to give for me the high on the first date. I can use high, low, open, close, volume, or adjusted closing price. I am going to choose adjusted closing price here. That's the value we want to use because it's the value that we had that affects our returns. So you want to find the column that you used for returns. All right, and so I'm going to copy that 368.7, and I'm going to assign that to equal my starting price. So I'm going to create a variable starting price and assign it to equal 368.7. Just make sure you do run that code cell if you want the variable to be actually created. So that will allow me to use starting price later on here. So then I'm going to call pyplot.plot, and that will take every item in the price array and plot it. I'm also going to add here pyplot.xlabel because typically it's good to add labels, titles, legends where possible. And so our x label is days, and then we'll call pyplot.ylabel. Ylabel is price. Then I'm going to run this code cell, and I'm going to see my plot results. And look at this, we have quite an intense plot. It's because we have one line for every Monte Carlo analysis. Okay, so we have price on the y-axis going from about 330 to 400. We have days on the x-axis going from about 0 to 365, which is what we specified. And we can see here we have a line for every day using Monte Carlo analysis. And this is how we can use Monte Carlo analysis to estimate risk. And at the end, we can see here we have all of our lines ending. So we're performing Monte Carlo analysis for a range of 100, but let's say I reduce this to a range of 10. Rerun the code cell. Look at this. Now I only get 10 lines of Monte Carlo analysis. It might be easiest with just 3 to understand from a very beginner perspective. So here we have 3 lines, right? And you can see they start at the same point, but why do they end at a different point? Well, the orange line ends at a price of 375. The green line ends at a price of 370, and the blue line ends at a price of 350. So they're not that far off, but they still differ. The reason being that when you call Monte Carlo analysis, you're calling that function. And here you're calculating price using shock and drift and a starting price. The starting price is the same because we hard set it, but then we use numpy.random. And because we're using numpy.random for every single day, that generates a brand new random number for every single day as our shock value. So because we have that random shock value every single day, that's why our 3 lines end up looking different, because we have that random shock value. And that is how we can perform Monte Carlo analysis. Coming up, we're going to finish up and we're going to learn how we can visualize price distribution. Join me in the next lecture where we will finish our project.